Hello, hello. Welcome. We're just starting out. So we're gonna try to implement hovering of the plot today. So like f of x, or not hovering, pan and zoom. So right now it's always displaying 0 to 1. But I'm doing some work where I would like it to actually finally change. And people have asked about this forever, so we just need to do it. So first thing, we need to make sure this is clickable, because right now this is just an IMGUI image. So I'm just looking up the IMGUI API to refresh my memory how this works. And it looks like we have item hovered, item active, item focused, item clicked. So focused is for gameplay or gamepad, or for keyboard or gamepad. Item active is being held, and hovered is that, and clicked is that. So let's just check this out. I guess mouse button 0 for now. This is the one I'm least sure about. Does this just mean held? Find out. Clicked. So we're going to do edit and continue. So we should be able to see it here now. No? Well, that's not a good result. Okay, so it's in here. It's just maybe our print's not working. Or maybe item image is just not considered an item. It's not a clickable. I see. Okay, so then we have to do this trick. We need to make an invisible button. And we need to do this like IMGUI set cursor thing. What is that? How do you do that again? Get cursor position absolute coordinates. Prefer using this rather than get cursor pause. Also more useful to work with IMDraw list API. Okay, so I think we just do this. Cursor. The size is just Perez. And then after that, we put the cursor back. So I'm GUI set. So that makes an invisible button. And that should, no? Oh, this is off to a bad start. Is this getting added? Cursor res, okay. Why is the clicks not happening? What if it's just button? we see a button? I think this is just not showing up here. Like, where is it? What about now? Does it go here? No. Okay, so it's definitely in here, but for some reason, I guess the image is covering up the button. Whoa. Oh, that didn't continue. Crapped out. Okay. So now we should, yeah, okay, there we go. Now we see a button. Okay. Why is it not clickable? That's wild. What's going on? This is an unexpected hiccup in the road. I wasn't planning to work on GUI stuff today. What's going on here? What if I just don't give it a size? Is the button just not working? Are we just not getting mouse input? Holy crap, do we just not have mouse input? That doesn't make sense, because look, this is working, right? What? This? Is I'm GUI button not working? What? That's bizarre. Okay. What if, like, we just do this and then we try? Okay. Okay. The button does do something. Okay, so it's not like I'm GUI's busted. Okay, so something out here is janking it up. Push style color. Something with pop-ups. So let's just put the button here. And then try to figure out which part of the code is not making the button not work. So test button's already not working. So like if 0. Unexpected random I'm GUI debug session. Wait. Oh. Yeah, what's wrong with this? Oh, some operator got removed. Hello, Bullfrog. We're hitting weird I'm GUI issues. Because apparently invisible button refuses to work. So that's where we're at. And we don't have a way to click anything, and therefore we don't have any way of dragging anything. So what's resizable container? Okay. Okay, so what is this thing? Is this related? Basically, if I can make the button work, then I can have clicks. And if I can have clicks, then we can actually get to resize the window. As in, actually be able to zoom the plot. So is all of this the problem? Hopefully I don't spend the whole, okay, yeah, so it's this thing. Okay, let's go back. Freewheeling it without as button. We're not gonna have version control today. So presumably, if I just do this, it will work. Is that what's happening here? So some kind of child window action? Yeah, okay. So some kind of child craziness is happening here. So I'm probably just gonna let it slide because I'm not interested in debugging that today. And instead, I'd rather, work on the feature. And I'll just fix that up later. Okay, so now if we do FX, okay, there's the plot button, hovered, clicked, okay. And so, if I, instead of a plot button, have an image, can I just do that? And let's see, what's our output? Clicked, clicked. So there's clicked, but there's no active. It's just clicked and hovered, but no active. And so my idea was I would use an invisible button and do this basically. Start the GUI cursor at the beginning. If you're familiar with how IMGUI works, this will make sense. It's just a way of controlling the layout. And that will get us an invisible button that is the same size as the image, the plot image, and I think invisible buttons have the active state. Yeah, okay. So now we have click and hold, which is what we want. We want click and hold because we want to be able to drag the plot around. And we also need mouse wheel. Where do we use wheel? I know we use wheel. Is that in main? Because I want to be able to zoom with the wheel. No. Where's like the wheel pass through? What is that even called? Is that scroll or something? Where's zoom? I thought we have zoom. Oh, is it with control plus? Maybe with control plus. IMGUI probably has it. Wheel. Where is it? Wheel H. Mouse wheel. Okay, vertical. Oh, mouse wheel. Okay, so let's print the mouse wheel because I figure I'll just get all the inputs here. I don't need hovered, and then that way I would just focus on the functionality after that. GUI get IO, I think. Mouse wheel. There it is. Greater than 0. And we could do something with it. Do we have that? There we go. A wheel. Oh, interesting. Right, so you can be negative. Okay. Okay, so we have our inputs, and now what we need to do is be able to drag this thing around. So right now, the way the plot works is it's always on a range of 0 to 1 on x. Oh, sorry, -1 to 1 on x and -1 to 1 on y. And I'm doing some stuff on a secret side project where I need to play a lot with animation curves. and I want to be able to actually pan this around. So what I really want is I wish I had this where I can just do that and it would plot the function on 0 to 1. But that requires some parsing and eval work and indeterminate eval stuff to be working. And I don't really want to deal with that right now because eventually I still just want to have the click and drag version 2. So I figure, well, why don't I just implement that version and then it's useful now. And what I'll probably do is I'll make it snap so that it's easy to drag it into a, like snap to the nearest grid cell or something. At least like as an option maybe. So I have this little options menu. And so maybe I'll make it snap so that it's easy to just drag it into a place where it's 0 to 1. Which is probably good. Yeah, so the way it currently works is that the plot, so here's where, this is where the plot is like rendered. Oh, sorry, output, but it's rendered out here. And so, by the way, is the font, I should probably make the font bigger. Let me know if that's all right, because even that maybe. So here we clear the plot, we draw the stuff. And so, and right now everything is just done with like raw software pixels, and I'm using SDL's draw line routine. That's like all I use right now. And I'd like to use like the GPU eventually. The main reason I didn't was because when I tested the startup times, if you initialize like SDL GPU, it takes something like 2 seconds to start the application, which really sucks for a calculator. So I'm sure it's fine for like a game or whatever, but it's kind of annoying for a calculator. So I tested them all, and it was like, if you let SDL but just pick the native library on which on Windows it picks D3D11, it starts in like 160 milliseconds or something, or 200, something like that. And then if you force it to like OpenGL, it takes like 300, and software is like 200 or something like this. Anyway, they're like in the couple of hundreds. So I could just do OpenGL, which is what I'm like familiar with most and have the most code, just to kind of get things off the ground. I could do Vulkan, but it's really annoying, and a lot of, I could do modern Vulkan. I heard it's much better. I'm only used to the old Vulkan, and I'm like somewhat scarred by it. So anyway, I do OpenGL, but basically because of startup times, I haven't. So what I think I want to do is I want to prepare it for OpenGL. Do I speak Russian? Yes, I do. So yeah, I was born in St. Petersburg, so I was there till I was about 10. Okay, so what we do is we have the pixels, and then so we go through plot, draw top. This just draws the plot of the topmost function on the stack inside the internal eval stack. And we calculate the number of parameters that that function has. And right now we just are able to plot functions of one value. So like f of x equals y kind of things. But actually earlier we had a way to plot 2 parameter functions, or like 1 in 2 out. So for example, like parametric curves like f of t is equal to xy or something. So there will be more in there, but we want to be able to like calculate the in and out parameter count and then pick the appropriate rendering function. So, but for now it's just 1 in, 1 out. And this is just a really dumb thing, which literally for each value in the resolution of the buffer calculates the value at which to evaluate the function. And then clips the line and plots the line. Do we not? Oh man, we're not even using SDL. Oh, okay. We're just doing raw dog Bresenham. Okay, never mind. I didn't even realize that. So we're not even using SDL. Okay. Well, interesting. Well, it doesn't matter because we're not like working on that. But effectively, here's where it sort of says, okay, we should probably start renaming these so that some of this makes more sense. So n, x, and y, these are the inputs. Is that right? Yeah. So nx is the input values, and then ny is we actually run the calculation. Well, we call the function here, and then we hope that there's a result. And then if the result is a number, then we do something with it. And if it's a two-dimensional number, we actually output a 2D number. But this is kind of weird. Yeah, like basically a 2D print is pretty busted. Okay, so what that means is we have some kind of range over which we want to evaluate the function. And like the output window we're concerned with is always going to be the same. It's going to be from 0, 0 to resolution. But the area on which we want to evaluate the function is going to be sliding. So that's going to be like the window, right? So we can start to play with that here. So here the x value is just 1 divided by resolution, which is actually interesting. It's actually on the range of 0 to not exactly 1. Like it, yeah, it ought to be -1. Interestingly. So actually the function would have been slightly asymmetric if we looked at it before. Bug. And then it's like, take that and arrange it to -1 to 1. Okay. So what we want to figure out is we want to create a 0 to 1 value and then remap it back to the window that we care about. So we want something like we need box 2. That. Okay. So why don't we start by just doing the null version? So we'll do a box from -1 to +1. So first we'll just like establish this idea that we're going to be plotting over a window, and then later we'll just move the window and hopefully everything just works out. So right now it's from -1 to 1. So we'll just replicate that. Okay. So we get the 0 to 1 value, and here is the thing that remaps it to -1 to 1. And first off, we don't need a double here because we're not dealing with that. I think I'm using doubles because the output of the calculator is doubles, but like it really is not happening on the screen. And the number of pixels just doesn't matter. Okay, so then this is the 0 to 1 value. And so actually x, so there's this handy function remap, which takes a value on some range and then remaps it to a different range. And so in this case, we're going to remap from 0 to 1 to plot window min x, plot window max x, and we're going to do it by x. And really, we shouldn't call this x. We should call this like, we'll call this u and v, like uv coordinates, right? So we'll take u, and then we'll say float x is equal to that. Okay, so now this is the x value. And really, Well, you would imagine that you just remap the y, but the y is a little bit different because the y, we first need to, the u component is from the screen, but the y component is the result of the function. And so what we need to do there is first take the value of the function and then zero it to the this is the sampling x value. So we need a sampling value in the plot, and then we need an output value in the resolution. So let's actually be more clear about that. So let's call it sample x, because there's no sample y, but here's the sample x, okay? And this, these x and y cur things are what actually gets plotted as the line. And this is what remaps it to the pixels. So x and y cur and x and y prev should really be called, like, I guess viewport? Viewport x? Let's rename that. Okay. Wait, what? That's not, these are the viewport. Oh, right. But these are the prev ones. Okay, sorry. Viewport x prev. View y prev. And then these are the viewport x and viewport y. Okay, and then this will make it obvious that we will need to do a remap to the viewport, because here we're just multiplying, because we're saying nx and ny are normalized, okay? So these are like NDC values, as you would call them in graphics. So they're normalized device coordinates, which go from -1 to +1. And so yeah, so here we're going from -1 to 1 to 0 to 1. So these are actually not, because NDC is -1 to 1. These are like the other one. Okay. And it's basically saying, where are we going to plot it? We're going to plot it where the number is. And so this one is the one that now needs to be rethought, because this one is fixed right now. It's saying it's -1 to 1. Okay, anyway, let's run this. Let's see if we just didn't jack anything up. Okay, it looks fine. Right. So now we need to actually take this number and remap it to 0 to 1 so that it can go into this normalized y coordinate. And so this number is like the y value at y. So we can probably, yeah, well, this will be sample y, because this is the value of the sample. And here we're assuming sample y is between -1 and 1. But what we need to do is for ny to now say, okay, we're going to remap from plot window min y plot window max y. So from -1 to 1, we're going to remap to 0 to 1. And we're going to use sample y to do so. And we're going to saturate. And saturate just makes sure that the result is between, clamps the result to 0 to 1. And that's because it's kind of a precaution, because on the, how do you say it? It could be off screen and we don't want it to be. Although I guess the clip will work. Yeah, actually we're not going to do that because the clip will pick that up. Okay. So if things are off screen, that's okay. Okay. So this should deliver the same result, but now we're using the window. And now what we should be able to do is change our plot to go from 0 to 0 to 1. And then we see this. Now this is a little weird. It's not what I expected. I expected it to start at the left side. Oh, and that's because of this. Because we need to remap. And x is actually just u now. There we go. Okay. Now the axes are in a funny place because the axes don't care about the window. So I'm just thinking what the best way of exposing that is, because my plan for the dragging was that I would be dragging like the plot within the window, within the viewport. But for this math to work better, or for this to be more like how you want to write it, really you just want to be controlling the plot window within the function space. So then later on when we do things like this, I just pass that as the window and everything just works out. So you kind of want to be moving the window around. I was hoping to avoid that because when you do things like zoom in on a particular point in the function, it can be kind of nasty to figure out like the math to zoom about a point rather than zoom, through the center. And my plan was just to use kind of like matrix multiplies and concatenate them carefully. So that way I can just express that kind of stuff cleanly. And if I'm stuck with moving, 2D boxes around by hand, it's easy to get tripped up. So I prefer to do the math I prefer to do the dragging in a more kind of like principled math way rather than in a bespoke drag the points way. And really this should all be in the shader. I'm wondering if I should just like frame this as if it's on the GPU. And then just pretend like it's on the GPU until it is. And that would just write all the math as if that's the case. Or should I just slide the box around? And how would I slide the box around? What does it mean to slide the box around? So if I drag to the left and the box goes to the right, so it's as if I'm moving the plot relative to the box. The other thing that's happening here is that I'm implicitly saying that the u coordinate on which I'm going to plot, or sorry, on which I'm going to sample, is 0 to 1 across this whole thing. And if, for example, I want the plot not to stretch, but instead get more kind of length of it. So for example, if f of x is sine of x, see right now it's just sort of like showing me the 0 to 1 thing. And if I stretch, it's showing me that same piece. But maybe I want to make it so that when I stretch it, I actually see more of the function. And that implies some kind of scaling factor here. So for example, if I had like that, then I would expect, oh, the u is like not even, oh, it should be. Oh, right, because it's just, right. So, no, but it's here. So it's, yeah, remapping 0 to 1 to the plot window. So if I wanted to remap 0 to 2 to the plot window, or like 0.125 or something, then you'll get more of it. Yeah. Well, you get more. It's not resizing because I'm not piping that dynamically. So it's always annoyed me on calculators that like the stretch didn't show me more of the function, but I do kind of get it because you want very careful control over your window. But I feel like just showing the grid lines should show you that. All right, well, let's start with this first. So now we're going to pipe in the plot window. And plot in, one out, really now is going to be so we have that, and then plot draw top. This one should take. Okay, and then calculator here needs to be able to take plot window here. Why is mat 4 and pose 3 in here? The hell? Okay, we don't need that. Shouldn't anyway. Oh. Here too. This is just another call site of draw plot, so we'll just pass in the default value there. That's for the test harness. Okay, so now here we can mess with the plot window, which is like at the output level. And so here we actually need to do the drag. And this is a little bit weird because we don't know. Yeah, it's already live. Been live since 4 p.m. It's 4 p.m., right? 4:40 PST. We're in it. So IMGUI doesn't make this one easy, unfortunately, because we might just have to live with a frame of lag until we change UI toolkits. It's not that IMGUI doesn't, it's exactly an IMGUI problem. Wrong time indeed, it's all right. I got music going, by the way. If people want to follow along, here's the, let me see, where's the, last time I played music on the stream, the whole VOD got nuked, obviously. So if people want to follow along with the music, that's my vibes right now. Okay, so to be able to get the movement of the mouse, I need to be in here, this like IMGUI area, but that needs to render the buffer, and the buffer is actually updated here. So it's a little bit of like, there's a little bit of a loop here. So what you'd really want is to know the layout of things in the prior frame, but IMGUI doesn't have the prior frame layout. So we need to actually put this stuff in. So we could, in theory, say, okay, we're gonna show a plot and put the invisible button, take the input, do the stuff, and then once we've done the stuff, do the image, submit the image. The trouble with that is that to know if we're going to show the plot, we need to know if the plot succeeded. But I guess we do know that because we have that. So we need to refactor this a little bit. What are these values? Right. Okay. So these are like the plot things. Okay. So this is the whole plot output area. Okay. I'm going to sort of, I think, abstract all this. Should I put this into like a show output thing? Maybe not, because so I want to contain these values in this calculation. Maybe I don't need to. Maybe I just don't need to. I'll do it. Okay, void. What are we going to call this? Just output. Calc output. Okay, and it's going to take all this stuff. Oh, I guess, so yeah, so it needs to be able to show, yeah, it's kind of annoying because it's like, bleh. I don't really want to get rid of it being in that. Okay, we're not going to do that. We're going to clean it up later. Okay, so basically, I didn't want to leak this if there was no output, but that's okay. So we're going to do the values, run the AST. Should just make it a frame late. I'm just gonna make it a frame late for now, and then I'll fix it up later, because this is partly an IMGUI thing that I'd like to really sort out later, to be honest. Okay, so static box2 plot window, and this is going to be the plot window that we drag. Okay, and then we'll start with -1 to 1, and we'll pass it here. And what we'll do is we'll say we have the plot window here. And if it's active, now we're dragging. Okay, and then we can do, we can get the mouse position, and we need the mouse position. We ultimately need the mouse position in the, what do we need it in? What space do we need it in? In the function space, right? Because the plot window is in function space. So we need the mouse coordinates. So we'll say, okay, viewport mouse is going to be where's mouse position? Okay, mouse position is like probably so this is like screen mouse. So it's like screen space coordinates. Why is it not just taking it? What's going on? And why is that not allowed? No user-defined conversion that can perform. Oh, it's just literally mouse pause. Okay. It's not a function. Okay. Fine. Okay, so that's screen mouse, and then we want to convert it to what the button place is. So this is where we can use the remap stuff again. I wish I had like a box remap. I wish I had a box remap. Can you guys hear the music now? I think I already set the OBS so that it doesn't include the system sounds. I just figured I'd post the playlist in case people want to listen to the same thing. Hopefully you can't hear the music, because then it's going to nuke it again. So what we have is a viewport box, and that's box 2 GUI cursor plus cur_res. So that's the box within which, like this is this box within the screen. But it's, I don't want screen pause, I want window pause. Actually, I'm curious, where is this print? Nice, if you don't hear it, that's great. Okay, what is this print? What has a new static variable, so it can't recompile. Oh well. Once in a while we lose it and continue. Okay, so it's saying the window is at 232. Okay, that's fine. So it's screen. Yeah, why is it called screen? So it's called, I guess, screen coordinates is not the screen, like the entire screen. It's just the window. Okay. And hopefully mouse position. Well, I guess, yeah, screen space. I mean, I was calling it that too, so what am I complaining about? So screen space is not the full. Okay, great. So screen position and mouse and box position. And so what we want is, I think what we want is coordinates that are normalized, like mouse coordinates that are normalized to the viewport. Because it's like a little mini viewport. And so what we want to do is do this remap where we do vec2 viewport mouse. We remap from the screen, which do we know? I mean, screen would be, do we have screen resolution? Do we have that? Something screen. Set, get window, pause, get window height. I mean, I have the, I think I have it in there, but like it's probably here, honestly, but oh well. Okay, so we'll just remap from this to and IVEC2. Yes, this must be IVEC2 as well. It's an IVEC. Okay, so then what we want to see, mouse goes from screen coordinates to don't need that. Okay. This goes to 0, 0, 0.9.3. Oh, right. No, this is correct. This is 0. This is going to screen. Right. Right. Okay. Okay. Okay, so that remaps it correctly to the screen, and then we went to remap from the screen. So this is normalized. We don't care about we just care about the viewport box. Sorry. We'll remap to the viewport. So 481.20. Oh, but then wait a minute, is the viewport box is already in screen position. Yeah, so that's not, yeah. So what I want is actually just remap from the viewport box to that. And then that should give me 0, 0. 1, 1. 1, 0. Yeah, 0, 1. Okay, so that gets me normalized coordinates. Because basically what I'm trying to get to is put the mouse in the same coordinates as the plot dragger thing. Because what I want to do is I want to be able to drag it and it match exactly to the size, like the amount of movement has to match. This is part of the annoyance of dragging a plot window, is because I'm going to have to do some math to like match the scales up. So I don't like love that part. I'd rather just drag, but I guess even, yeah, because I have the scale factor, which can stretch the function space, I think I have to do it. I don't think there's an option to it. Because basically here's like the thing that's going to happen is we're going to do plot window dot min plus equals like some kind of draggable. It's kind of, so we need to do some kind of mouse previous, and I'm wondering if it's better to do the mouse previous in which space is it better to do it? Because IMGUI has mouse pause prev 2. Just do it here. We'll just remap it twice. For mouse prev is just that. And we have to cast that because those are IMGUI types. And we don't need that. And it's going to be upside down, which is annoying, but okay. Viewport mouse delta is equal to viewport mouse minus viewport mouse prev. And we do that. And we do that. Now, because we want to move the plot, the plot is moving back negative in relation to the thing. Okay. Yeah, so it's upside down. And that's because my coordinates are in +1 minus, y is up, and IMGUI coordinates y is down. But remap, if you haven't used remap, remap's amazing function once you get a hang of it. And all it is just like a lerp. You just go to a place. Basically, you're remapping one range to another. And the way you do it is you take a parameter, you subtract the minimum. So that's like your from coordinate space. And then, so you're basically saying like I have some range A, B, and I want to map it to X, Y. And then you have a value, T. So it's like T on AB, make it T prime on XY or something, right? And so first you normalize T on the range A and B. And the way you do that is you say simply T minus A, which is the start, divided by B minus A. And so that puts you on a range of 0 to 1. Now, if T is outside of A and B, then it actually gets values outside of 0 to 1, but that's okay, because we can clamp it later. And you do that, And then when you have 0 to 1, well, then it's just a matter of saying, okay, now take that 0 to 1 value, and now you multiply it by y minus x. And that's it. So it's very handy to be able to like move between ranges. And so one cute thing you can do is, well, we could do like an inversion here with the thing, but we can just fix that in remap. So instead of going from 0 to 1, we can go from 0 to... So instead of going from 0, 0 to 1, 1, we go from 0, 1 to 1, 0. So we not flip, we 1 minus the y coordinate here. And what that will do is it will flip the output range for us. I touched the math file, so now everything's going to recompile. So that's all right. It won't be that long. There we go. Now everything is scaled wrong, and that's because I'm mapping 0 to 1 in terms of motion here. But the box is negative 1 to 1. So it's actually a size 2. So we want to multiply this by the appropriate difference in the plot width. So it's, I'll do it raw, but there's a function for it. So it's really plot width, plot window dims. So it's the dimensions of that. And so the dimensions would be 2, so you'll get a multiplier 2. And we're doing all this in vector stuff, so it's like 2D coordinates. So that way we just do them both at the same time. And there we go. Now it's correctly mapped, and it's right under my mouse cursor. So this is kind of like a manual, and it's laggy. It's 1 frame late because we're computing the movement a frame later than we're computing the plot. So that's a little bit annoying, but it would take some rejigging of IMGUI to sort of work that out. Okay. So now we also, we're dragging these things, but we've also got these, when we render it, we also render these axes. And so the axes, I think, just are hard-coded to be 0, yeah. And we want to, no, let's draw rect. Oh, weird. Why don't I just draw a line? Oh, is everything draw rect? What? Weird. Where's this function? Draw plot. This is an ancient function. Oh, this is like before. Okay, whatever. Before we had plot line. So really, we want to be able to draw lines not just at 0, 0 anymore. Okay, so we'll figure that out later. Okay, the thing I want immediately, though, is like I want to be able to reset because I don't want to lose my place. And so wherever we have the context menu, I'll just do if button reset plot view. And that just does so that'll just reset. So I can just do that. So I can move it around and then just, I should also close the, close the pop-up. It's kind of weird that it doesn't. But this shouldn't. These checkboxes shouldn't, but that should. Okay. Now the other thing I want is I want to be able to mouse wheel, and I want it to, the easy thing is to have it double the window scale. Um, I'm trying to think, what's the best way to keep the zoom? I don't want it to like be affected by floating point precision. So because here's a plot. Actually, you know what's a good one is like sine of x, but you do times pi so that we know it's exactly. Why is it clipped though? That's weird. That's weird. Should be negative 1 to 1, right? Okay. Oh, now it is. Huh? How do we get in that world? Huh. Okay. Maybe it just didn't look like it. Okay. So I want to be able to zoom. And I want the zoom for now to simply double. Well, I don't want it to double because it's going to look, I'll show you what it looks like. It looks too much. But I'm going to make so this is going to be the number of clicks we've done the zoom. And the reason for that is because if I just multiply this by 2.0. So here, this is the naive version. So every time we do a wheel, we're going to multiply it, right? And mouse wheel could, for now, like looks like mouse wheel is putting out values of 1.0 for every click. This is a little bit weird, but I guess it's okay. This is normalized to what the standard is for that platform, which is probably pretty good. And what we want to do is just double the dimensions. And for now, we're going to do it. We want to scale around the center of the box. But to do that, we have to break the box down into center and half extents. So the max you end up doing is this. Plot window is equal to box 2 from center and dims. Well, half dims. Plot window, center. Plot window, half dims. Times 2.0. Now, if you want to be clever, well, this is mouse wheel, right? So like the less clever thing is just like load scale is equal to like mouse wheel is greater than 0, 2.0f, otherwise 0.5f. If you want to be clever, you can like do an exponential here, because like 2 to the 1 is 2, and 2 to the negative 1, it's going to be 1 over 2. So that's the kind of cuter version. So there we go, I have zooming. So a few problems with this. Brr, brr. Notice that our dragging math is still correct. I'm still able to drag, like I'm holding the peak. And even though it's lagging by a frame, which is not great, it should be holding the peak. So when I go to all the way to the right, go to the left, it's, oh, is it just decoupling? Oh, wow. Whoa, wait, is it scaling? Oh, look at that. What the heck? That's wild. How is it stretching? That's cool. What? Okay. Okay. Let's print the plot window sizes. That's wild. That must have been how it got stretched last time when I was like, what happened there? What is this? Yeah, we're losing width every time we do it. Oh, okay, who spotted it? We're using the dimensions within the calculation, but we're affecting the calculations. So after the first one, the dimensions are altered and we use the new dimensions in the second one and it bleeds in. Okay, that should be fixed. There we go, 2.0. Okay, so now we can zoom. So this is what I was saying, is like my zoom is no good because I'm not zooming around a particular point. I'm just zooming in around. Should I make it zoom around a point or should it just be relative to 0? I don't know. I think it should be relative to a point. So the other problem, okay, so I mean, it's kind of all right, honestly. What I was going to say is that the problem with this logic is that the plot window, well, you cannot, I mean, yeah, you could already see it. Okay, so look right here. The plot window is 127.999954. And that's because we're just repeatedly multiplying by 2, dividing by 2, multiplying by 2, dividing by 2. And that would actually be all right if it was just a normal, like happening to a single floating point value, because times 2 and divided by 2 is sensible. But because we have this centering and half dimensions calculation, now we're going to be bleeding floating point error over time. So you can kind of see that manifest some time. So yeah, see. So, I mean, it's not the end of the world, honestly. For this kind of application, it's sort of okay. Well, not really, because if you really want to be accurate. Well, the thing with plots is that they're never going to be used for the exact calculations anyway. Just because they're in floating point, and so they are only limited to the position of the pixel. But I want to make sure that things are exact enough that, like, you know, if something is truly symmetric, then the plot actually looks properly symmetric and there's an exact number of pixels on both sides. Anyway, so what I was going to do is I was going to use integer multiplies, or sorry, just integer counter for how much zoom in and out we do, and then compute this statelessly. So rather than continuously multiplying and dividing, just do it statelessly. The other reason is multiplying by 2 is honestly a little bit extreme. Like it's quite a lot of zoom. And what I like to do is multiply by square root of 2. I guess we could do it in doubles. But, and the reason for that is if you multiply by square root of 2, it's kind of like multiplying by almost 1.5. So it's a smaller jump. But if you multiply by square root of 2 twice, then you get exactly 2. So it gets you kind of like in between powers of 2. But like the amount of imprecision in this whole thing is really bugging me. But it might be all right. Maybe I should just let it roll for a bit. See, so now you get a nicer zoom. But now you can see the values are like, I don't know, it's pretty exact still. It's not bad. Maybe it's all right. We use this on Modeler, so, and on Dreams as well, so like, maybe it's good enough. Okay, so I think I do want to zoom around a point though. And so the way to do that is to figure out, like that's, I want to chew next to the mic. So like zooming around a point is a canonical problem that's a pain in the ass to do with this kind of like piecemeal approach with 2D coordinates. And like the pro move is just to formulate it as a matrix. And then, you know, put the plot in the coordinate space of the controller, or the mouse in this case, scale about that point, and then put it back. And so you get this like inverse controller matrix, scale, forward controller matrix. Then you put the matrix, the matrix of the plot on the one end, and it just comes out and it works exactly like you expect, like you want. And it's all very clean. To be able to do like zoom around a point in this world, what you have to do is figure out the mouse coordinate within that space, subtract that from your plot window, scale about 0, and then like put it back. But I think you put it back by the scaled amount or something. So you basically have to do the same matrix math, but like by hand. Whereas before, the inverse would have just saved you. So now I'm wondering, should I just do the math, or should I suppose I could do the math on the box. So I'll show you, let's just try it. Okay, so the way you do it is you say, we're going to be dragging a box, and the box is pose. Oh, do we even need the box pose? Yeah, I think it's just So you want to go to the space of the controller, scale, then go back. So you do, and you want to know where is the mouse in relation to the window in this case. So what you need is mouse, like to mouse window. And it's this stuff again. Except now you need to map the mouse to the viewport first. And then from the viewport, go to normalized coordinates. And then from normalized coordinates, go to the plot window coordinates. Should I just make this a function that just takes I'll just do that. Okay, so what you need is a function that takes mouse. Ugh. Well, I guess we just need one of them. It's kind of annoying. I'll just do it by hand. Viewport mouse. Okay. Now the viewport we know is, now this is normalized coordinates. Oh, actually this is not even viewport. This is like normalized. So these are actually n viewport. Well, look at that. And did I switch to Russian? Keyboard switched to Russian. Okay, it's like, why is the N not the N? And it's the Russian N. Cat has entered the room. Okay, so we have viewport mouse, and then from viewport mouse we can go to the plot window coordinates. Okay, so here, let's just print that out. How are people doing? Is this any of this still making sense? Okay, so this is plot 0 to 1. Hello, cat. So there should be one. Right. Put that first. Okay. So we have the right coordinates. So then the way you do it, to catch people up, we're trying to do plot movement and zooming, so pan and zoom. And I started out hoping I can do it with just cool pro matrix math, but rapidly descended into, oh, we're just gonna drag a viewport box around and like do it raw dog coordinates. So that's just where we're at. So that's what I'm gonna do, because I think it's not like super bad, and it makes the plotting logic simpler to think about it as having primarily a viewport be the point of state. But it means we have to do a little bit of extra thinking. So what I'm trying to do now is scale around a point, because we're not just always scaling around 0. So we've computed the plot point. So here, the mouse coordinate now tells me I have like the correct mouse coordinate. The plot mouse. But we need to actually zoom around that point. And so we want to zoom around not the plot center, but we want to zoom around the plot mouse point. So the annoying way to do that is to make a new box, center it by minus plot mouse. So now it's at 0. Scale it. And then add, well, then you have to move it back. This is kind of so gross. So gross. Okay. So you do that. You scaled about plot mouse point. And then you say plot window min, and then you have to add plot mouse back in. And this is the part where it's like, I think you have to add the scaled version. Or maybe I think it's the inverse scaled. I don't know. See, what if I was doing this with matrices, I would like, you can't make a mistake. Whoa. Looks like probably divided. Oh. Yeah, that's not right. So it's sort of working. It's zooming in, but then it's not moving back enough. I think it might be that, or it's nothing at all. It's not that. Okay. So maybe nothing. Yeah, I hate this. I hate doing it by hand. That's interesting. Why is it not doing anything now? It's like literally doing it about center. Huh. Weird. This is not doing it. Plot mouse Y is just like 0. So if I don't do anything, it ought to move, right? Yeah. Whoa, if I do it that way, it just flips. What the heck? Oh. Negative? Oh, is it because it's like at the bottom of the window? Why is plot mouse ever going negative? Oh, because... Yeah, so this has to be there. Because otherwise it like moves it underneath itself. I'm this close to just rewriting it in matrix form. If I do it that way, then it's just like cancels out. So okay. Is it because it's in local coordinates of the plot window? Am I missing something there? Something like that? I've already tried this. I'm just like trying random crap now. Yeah, we're not going to just try random crap. Okay. Anyway, that's what happens when you try to do it manually. Okay. What you have now is you have your plot window pose. And what that is function from plot from window. Okay, so this is like the 0 point, and then you can say that's plot window center. Okay, so where the window is relative to the plot, and then you have pose to function from mouse. And so that is that. So that's where the mouse is relative to the function. And so now what you want to do is create a scale about mouse, okay? And so we want to go into the pose of the mouse. So we're going to do inverse function about mouse. Well, here, this is more obvious. Mouse from function. So then if you have something in function space, you can do mouse from function right? And then you do those two scale, and then you put it back into function space. And so now, if you have a function, from scale from function kind of thing, now you can figure out where is the correct new point. So you can say function from new center is equal to function from blah, 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 which is the plot window center. Okay, so now you have the new center. And then new dims is simply that. And then you do plot window equals that. Too many changes. Visual Studio can't handle it. West Coast indeed. Is it gonna work? Dragging, zooming. Oh, it's not. Oh, maybe. Look at that. Are you kidding me? First try? Is that how we roll? That's what I'm saying. The function. Yeah, I think it's working. Only thing is it's not. Oh, right. It's like, why doesn't it look like the last one? Look at that. Look at that. So it's a little bit off, not because the math is off, it's because the cursor can't be perfectly on the place. But look at that. If I'm really careful, lowrider just came on too. All right, so here's a good example of why futzing about with manual coordinate math sucks. But if you do these like domino matrix names, you can literally see how to compose them, like from function space to mouse space, scale around the mouse in mouse space, from mouse back to function space. Now I have a valid transform from function to function. And then I apply that to the center point within function space, which we know plot window is inside of. What is pose 2? Pose 2 is translation and rotation scale. So pose, like in 3D graphics, pose is pretty typical. Like some people call it transform or TRS, like translation, rotation, scale. And it's basically in 3D, it makes a little bit more sense because it's a position, quaternion, and a scale. And in 3D, you end up having like 3 components for the position, often 1 component for the scale, just uniform scale, positive or negative. And then a quaternion for rotation. So you get 4 floats for the quaternion, 4 floats for the position translation scale. And that packs nicely into 8 floats. You can shove that to the GPU. And it can express a rigid, I think orthonormal is the correct math term, transform, meaning that it can't express skew or non-uniform scale, or obviously none of the projection kinds of things. So it's not like a 4x4 matrix. It doesn't have the same expressive powers of 4x4 matrix. But most things, like in your scene graph, typically they fall under that category where they're basically translated and rotated and scaled uniformly. Because you don't often have non-uniform scale on things. And if you do, you can usually keep it as like a separate property. Usually what you have is non-uniform dimensions. So like, for example, you might have a box that's like, 2 meters by 3 meters by 5 meters. But that's not exactly a scale. That's more like those are the dimensions of the box, and then the box can get scaled uniformly up and down. Yeah, so, and in 2D, you can actually get away with just 2 vectors because translation, obviously 2D, and rotation scale can be packed into a complex number. So just like in the analog of a quaternion in 2D is a complex number. So instead of having like a float for rotation and a float for scale, if you do complex rotation, it's like the math works out cleaner. But usually people just use unit length complex numbers. But if you multiply scale into the complex number, the way the math works out is you can just rotate and scale at the same time. There's a downside to this, though, in 2D, which is that you can't have negative scale. And the reason negative scale is important is because it lets you express flips. So in 3D, actually, things work out a little bit nicer because your scale is separate, so it can be negative. And the quaternion expresses the rotation, and the scale can express a flip. And if you have a flip, if you have an inverse scale, that's the equivalent of, well, it's an inverse scale, so it sort of flips a bunch of your vertices around. But it turns out with a combination of that and rotation, you can do like horizontal and vertical flips, because a full negative scale gives you like a flip around the diagonal. And then if you combine that with like a 90-degree rotation, you can get a flip along the horizontal or a flip along the vertical. So you get like scale, flip, position, rotation, all in 8 floats, and it's all just like nicely composed and stays clean. But in 2D, if you want flips, you have to encode them separately, so it's a bit of a bummer. Are you going to snap the closest line instead of exact? Yeah. Closest. That's actually a good idea. So like you mean snap to the actual function value. That's a good idea. That's a very good idea, because basically if the user's like pointing here, if they're pointing close to the line, they probably mean the line. But if they're pointing here, they probably mean the middle of those things, right? So that's a really good idea. I like that a lot. So that way you can just loosely be like, zoom in. And every time you click, should we try that? I like that a lot. I like that a lot. Should I just eval that point? How do we get that? It's a little bit. So this comes back to the fact that our input logic is unfortunately separate from where we actually evaluate the plot, just because of the way the IMGUI UI is structured. So we don't know where that point is. But it'll be in. We could sort of. We could look up the mouse position. It'll be a frame off, but basically here we can eval at that point maybe. I'm gonna write it down. I might not do it right this second because I want to finish the axes and stuff. Yeah, so we'll do that later. Okay. Throw this garbage out. Trash code. Really, I should be doing this same stuff here the same way. Like this drag stuff, should be done this way, where you just drag the center yeah. In fact, I think you could just, I mean, if nothing else, this should be better. Hello, cat. At least that's like less gross. That should still work, right? Oh. Yeah, see, this is the problem. Because the scale, right? Yeah, it's annoying. Okay, I'll revisit it later. I really should be doing it with the matrices. This is what I mean. Like, as soon as I try to do anything to clean up this kind of manual math, it always is wrong. And every time I do it with these nice domino matrices, I just nail it first shot. Okay, so now I want to make the axes move with the plot. And I kind of also want, actually, I mean, I don't know yet, but I feel like what I want is that even when I drag things around, I kind of want them to snap to like, 1 and half and all that, at least as an option. Cat's going bananas. Don't do it, cat. Okay. And annoyingly, the draw axes is sort of just random. Cat enters the stream. Come on, cat, help me solve this. No. Okay. So really we have an infinite grid. And we just need to draw a piece of it. Because the axes, are just the ones at 0, 0 or 0, 0, 1. But I want to draw axes at like a grid every 1. And if this was in shaders, we can just make a procedural grid. But it's not. We're stuck in these software coordinates. So effectively, conceptually, we're drawing an infinity number of lines and then letting the viewport clip them. But obviously, we don't want to draw an infinity number of lines because that would be terribly slow. But because we've chosen this crazy path of manually rastering lines and manually clipping lines, because what? We're having to pay the price now. Okay. That's why everything is, well, in a way it's kind of nice. Everything moves in 1 pixel increments because everything's just integer coordinates. I kind of like the pixel look, to be honest, because I know exactly like from a plotting perspective, what's happening. Like I know there's a pixel here or not. So there's something I like about that, but anyway. Okay. So really I want a better plot line function, is what I'm saying. So we need this. It's annoying that we need pitch and stuff. Crazy. Okay. So we're gonna do that. And then we do clip line. So do that. Type it out. Okay. So where's the draw axes? Okay. So now plot line, pixels, pitch, res. Okay. So this is really just like, let's just fix the line drawing. And we're drawing in screen space. So these are screen coordinates. So we need draw axes to take I guess let's fix draw axes first, and then we'll draw grids later, but draw axes needs to take a point within the viewport of where the center is. So then, like the easy thing is just to let the clip routine sort it out. So you just draw two lines, center minus, so it's like for the horizontal one, like go as much as possible to the left. Color, and then do the same thing for the Y. And it's going to be off screen, but who cares? The clip function will clip them. Okay, and then draw axes. Now it takes the center. So now we need to know the axes, viewport center. Viewport axis center. Okay, and so we need to know where they are relative to the plot window first. So plot window axes center is going to be equal to remap. All these remaps I'm doing by hand are really transform, like coordinate transforms in a manual way, which is gross. Okay, but we're remapping from plot window. What do we remap? We're remapping we're remapping 0, 0 into plot window coordinates, which is really just I was going to say it's really just the center, but it's not quite the center because they have a dimension. This is actually a case where I think maybe 2D or matrix 3s would be better because the window does have a non-linear scale or non-uniform scale. Like it's this stuff again, it's this mouse thing again. This is basically, once we have this, we need to get to normalized plot window, is that right? Yeah, we need to get to a point where it's in normalized. Well, it could be in window coordinates. Okay, so we can just do a remap from to vec 2 0.0. We just Curres, is that this whole thing? Oh, we don't know how big the current resolution is. I guess we can get it. It's really weird. Yeah, so that would remap it wherever the 0 is relative to the plot. It would remap it into the viewport. And then we just slam it to an integer. And then to figure out where the 0 point is, which space are we remapping from? And doesn't matter. Maybe it doesn't matter. I think it just doesn't matter. So I think it's just that maybe. And then you shove it into here. something like that. Suppose I should have just tested the draw plot function first. I didn't do anything. Okay. Okay. Let's see. If this is 0, 0, what does that do? Does that put the axes in the corner? Yes. Oh, 0, 0 is there. Okay. Okay, so it's just this point is incorrect. So where's the 0 point? Well, the 0 point is really just the negative of plot window center, but not quite. So we need to flip some things. But okay, we'll start with that. Yeah, so we need to, and it's upside down. Yeah, so that's expected. And that's because we need to do this, right? That's the right. So really it's this, but then it's like divided by the dims again. It's kind of gross. Or maybe, I think it's divided by the dims. Could be multiplied by the dims. Oh, no? Okay. Oh, half dims, sorry. No? Oh, and look, it's sliding away too. That's jacked up. Why is it not that? That's surprising to me. Okay, let's reset. Okay, so going to the top, we slid. Like the window dimensions should be 2, 2. Okay. So we expect when we move up by half, what happened? How far did we move the plot window? So here we moved the plot window up by 0.5. And and that should have moved. Why is this not mattering? Does it not? What? I guess because the center just. So what we're trying to figure out is where is the 0 point. Again, it's this. I should just do this in with matrices, then I won't mess it up. Why do I keep dragging myself into doing it with raw math? Ugh, okay. Because it always feels like you're almost there. So the 0 point's there. I mean, this is why it feels silly, because if you want the window space 0, it's just, it really is minus that. Oh, you want this. No, that's. I thought maybe that you want it to be in like coordinates that are like minus half dims, maybe. Maybe no, that's. I think that's right. I think that's what you want. I think you want. Yeah. Something like that. It's basically saying the 0 point in that space is the center. Yeah, there we go. Okay. Didn't have to do it correctly. Oh well. It'll do. Okay, so we can drag, we can zoom, we can zoom out, drag around, reset. Well, that's pretty good. Oh, that's jacked up though. I guess it's because the point is like way off screen and then we're just using the clipping. I mean, I guess a cheesy version of this is you don't even do this. You just do like make negative a billion. Or you just say the line is, so for the X line, you just say, or for the horizontal line, you just say it's always going to be from the 0th pixel to res.x, and then just do that. Okay. And so that's the axes. And so what I want, I think, is a grid. I want like a minor grid, which is like on halves or something, or ones. Okay. So what I want is this. Plot, draw grid. Okay, and there's a center of the grid. And in integer space, we're gonna have a grid size. But because the scale is nonlinear, the grid would have to be nonlinear size. And we'll be more accurate and just say cell dims. So we'll talk about the dimensions of each cell. So like half is the diameter of this, or the diameter, not the radius of the cell. Okay, and so we know how many, this is where the math's going to get a little bit procedural. Okay, so the naive thing is you just say there's going to be some number of these cells relative to the viewport. And that's going to be res divided by cell dims. Is that a good way to do it? Or is it better like, I think it might be better to just find the leftmost cell and then like step by the cell over to the right until you get off the viewport, because we're doing this in viewport space. And if we know the center, we kind of know where that is. It's funny because I'm more used to doing this math in the shader than I am doing it on the CPU, because in the shader, you basically just look at the screen space coordinate, and then you take like a fract or a mod off of the center, and then you get your local space repeated coordinates, and then you just do the stuff. But here we don't have the fragment. What we have is we just have to figure out where to start the grid and where to end it. So I think here's one way of thinking about it. We want to like sweep some amount of space vertically and horizontally. And then we want to step by the cell dims and then just draw a line every time. So we can formulate that as start X. And then let's say we'll just start at the center for now. And later we'll figure out a different way of doing it. And then we go until x, or we go while x is less than res.x. So until we hit the resolution point. And then we do x plus equals cell dims. And for each of those, we just draw a vertical line. Sorry, this is a horizontal line. We need a vertical line. And the vertical line is at x. So we'll start with that first, and then just let's get that on the screen. And then let's just do like 8 pixels or like 16 pixels for now, and then we'll figure out the correct sizing later. And pack into UN. What are these? Like force? Make them red for now. Just so that we could see them better. Okay. So now they're always 16 pixels, and they're not correct. So we need to figure out how wide they should be. And let's say our grid is going to be grid size is equal to 0.25, so a quarter. And then it's function grid size, so in function space. So then float viewport grid size depends on the window. Function grid size divided by plot window. And it's vec2, so here's where it becomes non-uniform. So we want to say like, oh, it's a quarter, right? But like in both dimensions. And you divide it by plot window dims. And that tells you how big it is in that world. And then you in a 0 to 1 way, and then you multiply that out by kerres. So then you can give viewport grid size into here. There we go. So 1, 2, 3, 4, and that's x times pi for sine, so that's exactly quarters. Interesting. B is 0, yeah. Okay. Okay. Crash. We don't want to be dividing by an integer. Making good progress though. We got a grid. Now it makes it easy to see. And then we can control this grid size from here. So we want to, we'll fix the other stuff up, but let's just do this real quick because the actual thing I want to do is this. Static float. Yeah, I mean, I just make this, right? And we'll just do it like that, probably. And if and that way we can make a control book from the UI. And we'll step by 0.125. Yeah, I think so. So this way you can just punch in a grid size. So you zoom out, now you see the grid. And then you can make the grid less. Yeah. Not bad. Not bad for a few hours work. So then we need both. Okay, so this is where we sort of get interesting. So right now, start X is just center X. So it's just like wherever center is. And so that could be like negative a bajillion, right? So this would be like negative 300. And so we're looping until we get to the end. And so what we want to do is figure out what is it relative to the nearest grid? So we want to snap it. And really it's like negative a million or whatever. Like we want to go all the way from the left. Another way to do it is just say, okay, where is center? So, like center tells you a sort of offset. And you really are offsetting always by some amount of cell dims. And it's really just like a fraction of that. It's really something like it's like center X minus center X divided by cell dims X, I think. Something like that. So let's print it. Can we print it? Oh, start is just 0. Oh, it's kind of working. Look at that. So it's 0, and then it should be like, should be 1? Like it's the mod formula, but I always forget it. I thought it was like Next mine is floor X or whatever. Like if I'm out here, what is it? Center should be like negative whatever, right? Oh. That's what was printing 0. Okay. Yeah, it's time still didn't, right. Like that. Okay. So now look, the start location is like -8, -14, -28, -36, 6. So at least we're not starting. So we're only iterating like a little bit. Okay. And now if we reset, oh, it's working. Why is that working? That's surprising. Why is it going left? Why are these lines showing up? Did I do the mod right? Center's 261. This is awesome. I did it right. The mod is correct. This is like what the fragment shader would do. Okay, except for 0, for some reason, the 0th line doesn't draw. Oh, because I'm drawing the axes over it. Brilliant. Cool. Cool. So watch this. Remove. Beautiful. Now just do both directions. Don't make a copy paste error. There we go. And that's as expected because look at that. So now just tone down the gross color. So we just need to like plot grid color. And then mess with those. I need to tune that color. Should be darker or lighter, right? Something like that. Okay. It's like too light or too dark still. I also think it's drawing the grid at the very corners, which I don't like, but it's fine. I also don't like that right here. This is the math is not very precise because you could see that the function is going above the grid line. That's because the grid coordinates are being snapped wrong. So probably this should be plus 0.5 so that it's snapped to from the integer center. Yeah, I'm not thrilled with that. It might be in the function draw, but basically that's bad because we don't want to mislead people that like this function goes above the grid line, because you look closer and like it doesn't, but from far away, because the pixel coordinate handling is not very principled, probably has something to do with like corners versus centers of pixel centers. And I think I want to tone down the color, make it a little bit, like, can I do that? Is that too bright? Too bright. Maybe just another 5 or something. I don't have the UI to tweak it right now because it's in the test harness. Yeah, it's kind of okay. I kind of wish the grid color was a little bit darker. To make it more clear. And also the zoom is reversed. Up is like down and down is up. So we should flip that. I think we might be done, y'all. Anybody have any questions or ideas? I mean, the basic version's done. A little subtle in the coloring, but I'm fine with it, so we'll see how people feel. Oh, we have that bug from, not bug, but something about the I'm GUI hackery we're doing to do the resizing makes the plots not really work. But this is nice and usable. I mean, it's good enough anyway. Like I have better things I'd like, but like it's okay. I feel like maybe I want a grid that's I want to be able to do a grid that's non-uniform. Drawing labels on the grid. Yeah, that'd be good. Basically, I'm still using IMGUI for the UI. And I want to use my own UI toolkit, which I have kind of in a back pocket, but it's a little bit of a refactor job. Well, I mean, not a little bit, like quite a bit. And I just haven't had time to do it because I was working on another project. So as soon as I have that, then it would be easier to do drawing. I suppose I can use, IMGUI's got a really good drawing library where you can like draw lines and text. So I could just do it that way. But I feel like I don't want to dig myself more and more into the IMGUI because like IMGUI is a great debug UI, but I think long term for some of the UI stuff I want to do, like I have a text editor that Jimmy wrote that I want to put in here so I can do syntax highlighting and stuff like that. And so I want to remove IMGUI rather than kind of like buy more into it, if that makes sense. Like I'm still going to keep it for the debug UI. It's fantastic for that, but for the actual like in-app UI, because like I have to do this kind of strange tricks in order to make resizable containers. And like my UI works a lot more like Nick Barker's Clay. And so it has nice responsive layout and stuff like that. So I'm just kind of like, I've been postponing everything, including like the graph pan stuff. I was like, I'm not going to add it until I switch to my UI. But then I was like, oh, I need some of this stuff because I was doing like animation curves and I wanted to visualize some of them. And I was like, oh, I just want to drag the graph. Yeah. Okay, so how come if I do this, then nothing works? That's what I want to know. Then I lose my clicking. Why does that happen? Is that because of this? Is that because the begin child is taking the click? Because as soon as I do that, buttons inside don't work. The difference between X and Y scales because the aspect. Yeah, it's because right now the aspect is controlled by this. I kind of hate it when calculators do this because I want to see that, I think. But weirdly, in practice, it makes good use of the space. So maybe it's good. I think I definitely want both modes. But I used to hate this, but I hate this less now. I think it might actually be the right thing. So yeah, that's why it's there. What's going on here? Frame style. So why is it this that wrecks it? Yeah. Okay. So somehow calling set cursor screens pause. Screws up the clicks. So this kind of sucks because basically the resizable container is what allows this plot to resize. This is like the trick that Omar gave me. And then you're supposed to, and it's just supposed to be like, oh, cool. Then set the cursor position back to here. Right? And then it puts this thing on top. But now the mouse clicks don't work on this thing? Is it because I'm not inside the begin child, end child? Is that why? And its base size, what's base size? Man. So output size, yeah, okay, so output size is the plot size. Okay, so I could, in theory, get the mouse, I bet the mouse is, the stuff is clickable here. I bet in here it's clickable. So if I do this, like where's my hacky buttons? Here. I bet if I put it in here, it'll work. Like that. And then I get rid of this. Yeah. Yeah, this area is working. So this, yeah, so I have to do this and I have to handle the clicks in here. Yeah, I think you can just expand the graph plot, and that's what I was trying to do a second ago, but because of my thing, it wasn't working. I mean, I think what I want is a checkbox which says, you know, square aspect ratio, and that will automatically make the scaling uniform, or maybe just rescale the window to match the aspect. So I might add that now. I have about 10 minutes before I gotta go. So let's see if I can get it done. The hacky thing to do is just to say, so gross. Like basically I want to get the mouse positions out of there. I don't know why this click isn't, maybe item doesn't have any flags, right? Yeah. I don't know why it makes it unclickable. I think Omar might have mentioned something about this. Yeah, the dark space. So basically, yeah, the dark space is the way this thing works is to make this. So normally, what happens is I do this. Okay. So to make this upper section resizable in IMGUI, to make this nice little like resizing thingy, you do this trick where you get the cursor screen pause. Now cursor in IMGUI doesn't mean like the mouse cursor, it means like the layout cursor. So you say, okay, where is the layout cursor? And the layout cursor, you know, would be kind of up over here, because we put in like the response text, and then the cursor moves down, and then the cursor's like over here. And then you say, okay, style vary, just make no padding, begin child. So you make a child window, whoops, and you make it of a given size, and you allow it to resize. And that allows IMGUI to handle the resizing. And so then you get the actual window size because it's been resized. So you give it like a base size, but then it allows it to resize. And now IMGUI manages the size, the actual size. So what I do is I wrap this whole thing into what's called a resizable, I call it a resizable container. And it gives me back the actual size. And then after you finish that sort of fake child of a fake size, you say set the cursor screen position, which again is the layout cursor, and you set it to where you started. And so what that does is, you know, it makes that invisible, that child window, lets you resize it, then puts the cursor back where you started, and then returns the actual size. And then I immediately make the image of the exact same size that it. So this is like a really roundabout way for IMGUI to handle resizing of effectively an image. And if I don't set the cursor back, then what happens is here's like that fake window, is that blue section, it's empty. And because I don't set the cursor back to start, the plot shows up now on the next line, right? Because the IMGUI layout keeps going line by line. So that's what that square is. And so if I don't set the screen pause back, everything works fine. And you see the resize is like doubled up because it ought to be up there. And the drag works. But if I put this back and, you know, paste my thing on top of it, now the mouse input doesn't work anymore. Because the mouse input only works inside here. So because of all this hackery, I need to actually get the clicks from here which is kind of gross. So you do invisible button, mouse area or something, and you do is item active. Just do that. And we're not gonna need clicks, I guess. And I guess we need the wheel. Well, actually, yeah, the wheel needs to be when it's over it. Good night. Have a good sleep. Yeah, that's why I'm trying to move away. I mean, IMGUI is awesome for debug UI because you're just sort of, it's really compact in terms of like code to be able to just say, hey, I want a float slider, bam, and it shows up and you can throw it like in the middle of your hot for loop or something and it's great. When you don't care about the layout and you just kind of mostly want it to align, it's perfect. But as soon as you start caring about layout, it doesn't have great facilities to control layout in the way a UI designer would want it. It has great control for layout for like programmers where you're like, I just want some columns. So it lets you be like, let's make some columns and just lay them out somehow. And you can take control and set sizes like what I'm doing here with like passing manual sizes, has lots of flags, but everything is like, that stuff is more complicated and sometimes really Byzantine, because it's trying to do a lot of things for you by default, so you don't have to worry about it as a programmer. But if you're doing UI design, like, you have to care about it, and so you want to just do that well, and there's better ways to sort of do that at the expense of having to do it. So it's sort of like it's a trade-off kind of situation. So in a lot of my projects, I use like my own UI system for the actual UI of the app, which is still in media mode and is just more layout centric, and has better dovetailing with input handling and all these things, but way less full featured. And then I use IMGUI as my like debug developer UI. If GUI is item hovered, mouse wheel over container. Okay, so it's like hovered and snapped. Cool. So now that no, we don't need this. Don't need this. There we go. Okay, gross, but got there. Okay, 2 minutes. 2 minutes, everybody. Is there a way to easily make it 1-to-1? Okay, so static bool square aspect equals false, or like, should we call it match aspect ratio? Something like that. GUI checkbox. What should that be called? Okay, if we're saying match aspect ratio, basically it means, oh God, everything that's plot window. I thought we could just I was like, maybe we could just scale it by something. But it's a lot of different touch points. Like, you basically want plot window to get, I mean, Like the right way would be to just abstract it into a function, but I only have a couple of minutes. Is there a simple way to do that? Like most of the places just read plot window. So any place that just reads plot window should just be like these places should just be able to be scaled. Like this kind of thing. And these ones can move, we'll fix that in a second. But then you can just do if okay, and then here you just want to multiply it by the aspect ratio. It's like that. Like that. I think it's just that. Because the actual underlying plot window is just always uniform. So the drag will no longer work correctly, but the output should look right. Let's see. There we go. Oh, but not quite. Divide. No. Interesting. So let's think. If you have two, it should be, oh, because it's not half dims. You need to be doing dims. Dims. Oh, we don't have that? Okay. Oh, no, no, that's right. That's kind of gross. Why is it? how much wider is X than Y? Why is it not just this? That's what my intuition says. Why is that not working? Okay. Okay, plot window is... Well, let's see. Let's just reset it to 0. Plot window is -1 to 1. What's res X? Oh, output size. There we go. There we go. Okay. So that's as expected. Yeah. That's nice. Okay, but now the drag is wrong, right? And so really it's, you got to like write back to plot output window and then write plot output window back. So gross, but we'll do it. We'll do it. Bam. And then when you're done with it, you just write plot window equals plot output window. Plot window output. Okay, but then you have to scale it. So gross. It's like you gotta write it back, basically. Okay, and then it's the center, half dims, but in this case you divide. I think. Feels very gross. Yeah. Oh, no? Why not? That looks right. Just the drag doesn't look right. Oh, because the center is getting dragged. Or, yeah. Oh. Why didn't it pick? Oh, it missed this one. The one that I didn't select. Yeah. Okay. There we go. Okay. I like it. So now we can have square aspect ratio or non-square. Thank you. It does look pretty nice, I think. What should be the default, you think? Should the default be square aspect ratio? Like if this is if this is what the normal graph would look like, is that expected? I feel like that looks a little cluttered. And like, I don't know. Maybe it's not cluttered.
Wait. Sorry, I know you're on a call. Did you run the water the third time? Because it feels like it's dried out.
I'm gonna run it at 10, right?
Or was it 6?
You said at night. Don't run it at.
Don't run it at night, yeah.
Okay, I'll come chat with you in a sec.
Thanks.
Mm-hmm. That looks nice though, when you do it like this and stuff and it resizes. Whereas like this is a little weird. Yeah, I think the square aspect ratio is more intuitive in a way. This is a little less intuitive, right? Because it starts to clip. But I suppose maybe it's more intuitive actually, because the sign is like, it's already. Oh no. All right. Well, I think I like the blot aspect ratio, but hit me up on Discord. Let me know which looks better and which should be the default. What should we call this thing? It's kind of a weird name, but I think it worked. Right on time. Not bad. The code's pretty gross in some places, so I'll have to clean it up, but functionality works. All right. Pleasure hanging out and coding, y'alls. See you next time.